Hello everyone, I'm back with another standard question from dynamic programming. In this video, this is matrix chain multiplication, and just for heads up, in this video we'll be only discussing about a recursive solution for this. And in the next video, I'll come up with a 2D array based solution which I actually have prepared it, but it I am not recording it in this video because first of all we need to understand the concept behind this, and the concept is very simple. The concept is very simple, but the indexing is something we need to take care of. Okay, so I'll simply explain the concept using a example. So in the question we have, let's say n equals to 5, 4, 20, 30, 10, 30. So it is not 4, it is 40, 20, 30, 10 and 30, 10 and 30. So there is this A which is of matrix A which is of size 40 into 20. B is of 20 into 30, C is of 30 into 10, D is of 10 into 30. So basically it's like this: A, and then we have B, then we have C, then we have D. So that's how it is. But the catch here is, again I'll tell you, the indexing gets a little confusing in this. So initially, I'll explain how the metrics are being multiplied. So metrics are multiplied, like let's say if there is a matrix with 1, 2, 3 and 2, 3, 3 rows, 3 columns, and another matrix which will make of uh, 1, 2, 3, but 1, 2, 3, 4. Okay, so we know the matrix multiplication goes like this: 1 into 1, 2 into 2, 3 into 3. That comes in the resultant matrix, that becomes the first element. Then 1 into 2 and 1 into whatever is here and here, that adding them becomes the second element. So you see that we are multiplying 3 into 3. So first matrix was of the size 3 into 3, the second one was of size 3 into 4. So we are multiplying, basically we are performing 3 into 3 of basically 3 operations. And how many times we are going to perform that? If you see the dimension of this particular resultant matrix, that will be 3 across 4. Okay, so it will be 1, 2, 3, and here 1, 2, 3, 4, 4. So for each element we are performing 3 operations. And for how many elements we are performing them? We are performing it with for the size of 3 cross 4, that is 3 cross 4. So basically the cost of doing this becomes 3 into 3 into 4. So basically 3, then the common value, and then this 4. So this is a basic mathematical operation which we have to uh, basically understand if we have gone through the scalar and multiplication of matrices. That is a basic thing which we learn 11th and 12th. So from there, if we get it, this is how we multiply a matrix. And the main part here is how we calculate the cost. So for example, if we are multiplying, let's say, A and B, then how will we calculate the cost? We'll calculate it using 40 into common thing 20 into 30. That's how we'll be doing it. So this is one thing we'll have to keep in mind. So now I will quickly again write out the question: 40, 20, 30, 10, 40, 20, 30, 10, and 30 again. So now we have 4 matrices, and size of this array is 5. So what we'll be doing is, you have to understand the concept, and then the code is simple. Yeah, and but you have to make sure that the indexing is correct. So concept is simply like, you take A here, So what happens in matrix chain multiplication question or a question of the related type is we make a division at each point in the given list. Okay, let's say first division is at a itself, so we'll keep a as it is, and we'll see what is the, we have to basically minimize the cost of the operations. Okay, what is the minimum cost in which we can multiply all these matrices? So if we multiply cd before and then multiply it to b and then multiply whole to a, then the answer will be different. And let's say if we multiply ab before and then we multiply cd before and then we multiply all of them, then the answer will be different. So that's how it is. So basically we have to tell the minimum number in which order we multiply. We don't have to tell the order, we have to tell that in what is the minimum cost for multiplying all these matrices, in which order I have to multiply it. So that's what we have to find. So for this, what we have to do here is we have to make a division at each of the places, and then we have to perform an operation from both the sides. Like let's say there is a division at a itself. Okay, we perform a division at a itself, so we'll leave a as it is, we'll go b c d, and then within this we can, for this three matrix we have to perform a division at a certain point. So what we'll do is first division will again make at b. Now c d are grouped. So, and since these are grouped, in this loop also we'll make a division at c, and then only d is left. So we'll make a condition where if there is only one matrix we'll return 0, and c is also only one matrix, so we'll return 0. And what we'll do is we'll also add the operation or add the cost of multiplying these two. Okay, so this is how we do. So basic concept is that you have to divide the whole list at each point. So for example, let's say if c, if once it was divided from b, then it was divided at c, and then within this loop we saw that since they are individual matrix, their own cost will be 0, but for multiplying them we'll have another cost that will put in the question, that will put constant will put in the question. But at the same time, the next division is to be performed at c. This is the main thing you have to understand, that a was here, the first thing was b, and the second then cd. This was the first solution which we explored. Okay, and next solution will be a will be here and bc will be grouped because they will be multiplied first, and d will be after their multiplication, whatever we get will multiply it to d. Okay, so this is the way we are going to uh, use this. So next up, what will happen is, now first division what a will return from this loop, will return from this recursion stack, and next division will be at a b and c d. So you're getting my point, right? The whole point here is that if we have, let's say, a b c d, will run a loop from base till the length, or let's say we'll run it from low till high, and at each point when I is at 0 or I is at a, we'll do low I. Okay, low I will go for low I, and we will also go for I plus 1 and whatever is the high value. Okay, let's say in the solve we have got low and high as the value. So this is what we'll do. And since low and I are same initially, because it starts from a itself, right? So this will, if let's say low was 0 and high was 3, so there's a loop for I in 0 3. So I is initially 0 and low is also 0, so it will become 0 0. That means, that basically means that we are not multiplying any matrix, we are just having a matrix. Okay, we are just having a. So in the base condition of this solve function, what we'll do is we will just we'll say low high, and in the base condition we'll say if low equals to high, then we'll return 0, because we don't incur a cost for that. If just seeing a matrix is not having cost, but at the same time we'll also have s I plus 1, that is 1, and high will be 3. or yeah, for four matrices the list of the values will be of the size of 5, basically 4, 20, 30, 10, 30 to 40. I don't know, I keep calling it 4, 4, 40, 20, 30, 10, and 30. So this is this 0, 0, 1, 2, 3, 4. So it is 4. So initially we'll be passing it 4. Okay, so we'll be passing it 4. So this will become 4. So yeah, 0, 0 and 1 4. So that's how we do it. So you basically have to understand the concept. Now what happens here, we also will add the cost of what, cost of the best values from BCD. What is the minimum value we'll get from BCD, and uh, whatever is the matrix of the minimum value, we will multiply it with a at the end, because this has given us a value but this matrix is still out of the product. So we have to multiply this a to whatever we get here. So for that we have a formula. If you try to sit and multiply, you will be able to figure out that is basically we are taking multiplication of array. Let's say the array was passed, array was the list of, this list is called array. So we have low minus 1, we have multiplied with array of uh, I into array of high. Okay, so that's how we do it. So basically we are taking one matrix, we are multiplying the other matrix, and then we are adding the cost of this, we are adding the cost of multiplying adding the cost of multiplying the two results which we have got. So that's how we work. Now how with what will happen in BCD, that is what will happen in 1 4. Again there will be a loop, that will make a division at B, and it will be again just B and CD, and then again there will be a division at C, so it will be first BC and then D. So this is how it will divide. Then whatever is the best thing that will be returned from here, that will be multiplied by that will be added to this A, which is 0, and we'll have the cost here. But again, you remember we are running a loop, so I will clear this up. We are running a loop for I in low to high. What we are running a loop, that is s of low I and plus s of I plus 1 and high. This is what we are running right now. Okay, so I becomes, first it was 0, that it was equal to low, then I became 1, then what will happen is it will become 0 1. Okay, or we can say that basically now in A B C D we are trying to multiply these two, and the next loop will be trying to multiply CD. Okay, so that will be 2 4. So that's how we are going to plan it. And again the cost we are adding, so cost will be again array of low minus 1 into array of I into array of high. So that's how we will do it. So this is the concept, this is how we are doing it. So now you have to understand, we are basically in each of the call, in the recursive call, we are dividing we are looping over all the elements and breaking it into parts. So in the first loop we are breaking it as a b d, then we are breaking it as a b and c d, and in the second loop, like let's say in this, when it came to BD, what we were doing is we were breaking it B C D, then we are breaking it at BC and D. So basically that is trying all the combinations, and at the end what we are doing, whatever results we are getting from both the side, we are performing some computation on that. So like for example, when we broke it at B, so ABCD was there, we returned their cost, returned the minimum cost that they incurred, and after these two metrics are retrieved, we are also adding the cost of multiplying the resultant metrics from both the sides. So this is the concept, and this is a very interesting concept which is used in several of the questions. And I have found that a matrix chain multiplication is basically uh, uh, a little tougher compared to the other types of questions in dynamic programming, because here you will after solving several questions you'll be able to recognize the pattern, but figuring out the uh, figuring out the way to handle the index is a little tough, because for many cases you will understand that we are not calling at I plus 1, we will be skipping it and we are calling it at I plus 2. Okay, so we are basically skipping one values, that is for the maximum I exactly don't remember the question, but it is computing the maximum or minimum value of a expression of a mathematical expression. So that is there. So this is the concept. Here we have implemented it. We are seeing that when low and high, this is dictionary I have used to avoid the recursive call. So if low equals to high, we are returning 0. And again, we are looping from I from the range of low to high. And you can see we are calling solve low, low till I, and then I plus 1 till high. And we are also adding the cost of multiplying the resultant matrix. So we are dividing something in middle, from whatever we get from the left, whatever we get from the right, we are adding the cost of it as well. So and at the end, for this particular instance, so for let's say a b c d, when we divide at a bd, when we divide at ab cd, when we divide at ac and d, what is the minimum cost from all these three, that also we have to return, right? And all the stacks of the recursion have to do this. So basically we have taken a value that is, I've called it maximum, but it has to be basically named minimum or anything. So I generally have a tendency of naming this maximum value as maximum, so, or minimum value as well as maximum. So I have named it as maximum, which has the infinite value, highest value allowed for the this type of variable. And we are basically comparing maximum with temp, which we are calculating in every iteration, and we are taking the minimum. If the current temp is minimum than maximum, then minimum than the value, the variables, then we are storing it again in the variable, and we are storing it in the dictionary as well, and we are returning it. Though I've tried to memorize it using dictionary, but still, since we know that dictionary in itself is a it uses a hash map at its base, so it is it's still beyond the time complexity that is allowed. But we can quickly have a look at a solution which I figured out. I think it was long back when I tried this. So this was a DP based solution for this, which I can cover in the next video. This is a C++ solution. I will cover it in Python itself. So yeah, that's there. So this is how it is solved. And again, I'll tell you, you understood the solution and you might think that this is fine. You can do it. But the issue here is that you have to basically handle the index very properly. Okay, so index is something where even I got stuck after doing it, when I was doing it for after quite long. So yeah, that's one thing I'll have to take care of, you'll have to take care of. Please rewatch this video. You have to basically understand the concept which I have told, that the division is to be made at each point. Even if we go to bd, even in this loop, the division is to be made at each point. So this is one thing you have to take care of, and make sure that you understand it. Thanks a lot, and see you in the next video when I'll come up with the solution using a 2D array. Thanks a lot.